Hi everyone. Today we're going to learn about rational inequalities. We'll learn how to solve and graph a rational inequality. So let's first start with the definition. Rational inequality is a quotient of two polynomials. So the first, p of x divided by the second, q of x. And in our problem it's going to be greater than or equal to 0, but it can be anything. It could be less than or equal to 0, it could be just greater than, or it could be just less than. So what we'll do first is solve the numerator and denominator separately. So we're going to set those equal to 0. And then we're going to find the zeros or the solutions of the numerator, as well as any undefined points or solutions for the denominator. And then once we have those, we're going to plot them on a number line and look for test points in our intervals for each of those zeros and undefined points that we got from up there. And then we're going to look for the sign. So in our case, we're going to want positive signs because we have this expression right here is going to be greater than or equal to 0. So we know in order to make this statement true, we have to have a positive result. So let's begin. All right, we have 2x divided by x minus 1 is greater than or equal to 1. And so we have the first, get this in the form of the definition. So we'll have to subtract 1 on both sides in order to get a 0 on that right hand side. So let's subtract 1 from here, minus 1, and 1 from there. So we have 2x over x minus 1 is greater than or equal to 0. But now we can't subtract 1 from this expression in the form that it's in. So we'll have to get the least common denominator and change this term into an equivalent expression for this other side so that we have x minus 1 in the denominator. So we'll have 2x over x minus 1 and then minus 1 times, and we'll put x minus 1 over x minus 1 because x minus 1 is going to be the LCD. But notice I haven't changed the value of this expression because this is actually equal to 1. And all that is greater than or equal to 0. So then, now I can use the distributive law to just multiply this negative 1 by x and then the negative 1 by negative 1. So I can rewrite the numerator now as 2x, and then minus 1 times x is minus x, and minus 1 times minus 1 is plus 1. And since I just have the same denominator on both terms, now I can just write that denominator once, x minus 1. And all of that will be greater than or equal to 0. So now I look for common terms, or like terms. So I have a 2x here, minus x there. So I can simplify this left-hand side and go 2x minus x is x. So I have x plus 1 over x minus 1 is greater than or equal to 0. So that's the first part. So now what I want to do is set the numerator equal to 0 and the denominator equal to 0. So we want to set the numerator equal to 0. So let's do that. We're taking this new expression we have down here. This is the one we're going to work with now. So we have x plus 1 is equal to 0, or x is equal to negative 1. And then what we want to do is put negative 1 in the numerator and the denominator. So we put negative 1 in the numerator and the denominator. So we have negative 1 plus 1 divided by negative 1 minus 1. So you get 0 over minus 2, and that's equal to 0. So this is going to be one of your solutions that we can refer to on the number line. Now, another thing we can do is now set the denominator equal to 0. So set the denominator equal to 0. So what's our denominator? X minus 1. So we got x minus 1 is equal to 0, or x is equal to positive 1. So then you just plug 1 to numerator and denominator. So you got 1 plus 1, I'll put parentheses there, and then 1 minus 1. So numerator, you get 1 and 1 is 2. 1 minus 1, denominator is 0, so that's going to be undefined. So basically we have two solutions here now. We have this, x is equal to minus 1, so we're going to put that on our number line. And then here, x is equal to 1. We can put that on the number line, but we can't include the point because x really cannot be equal to 1. So we're going to represent that by either an open parentheses or by a hole. Whereas here we can represent that by a solid dot or by a closed bracket as such. Okay. So let me erase this for the sake of getting some room, and I'm going to rewrite my expression up there. So we have x plus 1 divided by x minus 1 is greater than or equal to 0. So this is all you need now to continue with the rest of this problem here. So. Okay, I'm going to erase all this as well. Okay, now here's the goal. We want to get some number here, whatever that's going to be, greater than or equal to 0. So what this means is we're looking for positive numbers. So we want positive numbers. And so how are we going to get those? Okay, well let's draw a number line. So we're going to plot the first solution we got, which was a minus 1. And we're going to plot the 1, even though, now that's going to be our undefined point. So this was our point that's undefined. But it's okay, because we don't have to include it. We can just represent that with a hole, which I'm going to do in a second here. So where this is undefined, we'll include all values up to and including 1, but not 1 itself. And here at minus 1, that'll be a solid dot, because it can include minus 1 in the solution. And we'll also represent the number line with a minus infinity here, because this will continue to minus infinity, and on this side we'll go to positive infinity. And now we can construct three different intervals. We can go from minus infinity to minus 1, and it can include the minus 1, so we can put a square bracket there. This interval will include from 1 to minus 1 to positive 1, but not including positive 1. And this last interval will go from positive 1 to infinity, but not including the positive 1. So we have to use the open parentheses for those. So now, all you have to do is pick test points in each of these three intervals. So let's come up with something here. How about in this interval, let's pick x is equal to 2. And then in the middle interval between minus 1 and 1, let's pick x is equal to 0. And then finally, in this last interval, let's pick x is equal to the 2. So we have x is equal to minus 2 down in this interval, and then 0, and then 2. So let's try each one of these. Okay. You're going to plug the x equals minus 2 into the numerator and denominator and ask, is it greater than or equal to 0? So we have minus 2 plus 1 over minus 2 minus 1. And we want to know, is that greater than or equal to 0? So in the numerator you have minus 1 over minus 3. Is that greater than or equal to 0? It sure is, because 1/3, yes, is greater than or equal to 0. So this interval here will definitely give us a positive result. Now when x is equal to 0, you do the same thing. You're just going to plug the 0 into x, into that original expression. So we're going to have 0 plus 1 over 0 minus 1 greater than or equal to 0. Is it? Well, you have 1 over minus 1. Is that greater than or equal to 0? Well, let's see. Minus 1 is not greater than 0. So I'll just put this and a little line through it to show that it's not. That is not true. So in this case, we're going to get a negative number, and so it's not going to be part of this interval. That makes the expression true. Finally, let's try 2. Positive 2. So we got 2 plus 1 over 2 minus 1. And we want to know, is this greater than or equal to 0? Well, we have 3 divided by 1. And yes, that is definitely going to be greater than 0. So we know that we'll get a positive result in that last interval. And so hence now what we can do is construct our solution set in interval notation. the solution set will essentially be from minus infinity to minus 1. But will it include or not include the 1? Well, it's going to include the 1 because we've established that before. And so since you've plotted a solid dot there and have an open bracket to represent this interval, we can just copy this exact information from this part of the graph here. So it's going to include the minus 1. Or this last interval will also be true. So we'll include 1, but you cannot include the number 1 itself, but we can place the 1 there along with an open parentheses. So this interval will go from 1 to infinity. And so values that are between minus 1 and minus 1 inclusive, as well as from 1, but not including 1, to infinity, will make this original expression true. So now, if you also wanted to just graph this on a number line, here's minus 1 and 1. There's two ways you can do this. You can either use solid dots or you can use bracket notation. So for minus 1, it'll have a solid dot and go to the left to minus infinity, and then on the right it will be an open circle and will go to the right to positive infinity. Some people are more familiar with holes and dots in the brackets. Now, bracket notation would be from minus 1, so it would be a square bracket going to the left like this to minus infinity, and it would be an open parentheses here on positive 1 going to infinity. Positive infinity. And so those would be the two ways you can graph the solution to this rational inequality. So what have we learned how to do here today? Well, we learned how to solve a rational inequality using the definition and by following the procedures, which is to set the numerator and denominator equal to 0 separately, and then solving for each one of those to find the zeros or the solutions, as well as any undefined points. Once you find those undefined points, you plot those and the solutions on the number line. And then between those points, you construct intervals and pick test points. Once you pick the test points, you just plug them into your new expression that has to be by definition, set greater than or equal to 0, and then you're going to plug them in and see where is the expression going to be greater than or equal to 0. Once you find out, you can graph your solution set in interval notation as well as in number line form, and you will have completed this task. So basically, what's the end result here? How can we interpret this in plain English? We can say that for numbers that are, I'll just write this down. For numbers, let's say x is less than or equal to minus 1, or for numbers, let's say x is greater than 1. I want to write it like this. Or for x is greater than 1, the statement is true. The statement is going to be true. So after we put it in interval notation and number line notation, it's good to just summarize in English what it is that we have found. So I hope this has been helpful, and I look forward to seeing you again.